Greeting, dear audience, and welcome to another episode of Unveil the Future podcast. This is the finale of this first season. I'm Văn Nguyễn, your host, and it's been a pleasure to join you in this exploration of scientific concepts. Over the course of 8 episodes, with the help of 8 brilliant scientists, we have managed to make the unknown a little less intimidating. For this very special episode, I have the honor of welcoming Professor Helena Nader, the esteemed biomedical scientist. Not only celebrated for her groundbreaking work in glycobiology, Professor Nader is also well respected for her tireless effort in promoting gender equality in science. She has spent her entire career dismantling barriers and championing rights for women in STEM fields. As the first ever female president of the Brazilian Academy of Science, Professor Nader has truly shattered glass ceilings and paved the way for countless women to keep pursuing their own scientific passion and make significant contribution for the world. Join us today as we delve into the empowering conversation on equity and equality in science. Hello, Professor Nader. It is an honor to have you with us for the first time on Unveil the Future podcast. And in this podcast, our mission is to bridge a gap between the scientific world and the general public, hopefully through the stories of your esteemed scientists and experts in their own fields. And Professor Nader, your expertise is in biomedical science, and it is specifically in glycobiology, which is a fascinating topic. But in simpler terms, could you explain it so that our audience can understand what is glycobiology?
Okay, first of all, I want to thank you for this invitation. So, glycobiology looks like a complex name, but indeed, it's a branch of biology that studies sugars. Sugars are also named glycans. But it's not the sugars that we eat that we study glycobiology. It's more complex molecules that play different roles in living organisms. So they play a role in disease. We know also that if you look at the regular cell, the normal cell, and the cell, a tumoral cell, they have different structures of these glycans. In disease, if you have the normal cell and the tumoral cell has a totally different structure of the glycan that's linked to the same protein. The protein is the same, but the chains that are in the protein are totally different. And also, for instance, for the mucopolysaccharides or glycosaminoglycans, as they are called in the last 50 years, a missing enzyme, just one enzyme in the synthesis of this compound, can lead to diseases that are very harmful for children. They are born with this disease, it's not acquired. And up to now, we don't have a real cure. Several treatments have been tried, but still we don't have. For instance, Hurler syndrome, Hunter syndrome, and others. There is a whole about 10 different types of mucopolysaccharidosis. So the normal structure of the compound is a demand for having a normal cell. And they have deficiency, the one in some of this disease, deficiency in learning, and they die very early. So glycobiology, the glycans are really related to the normal life span.
From your perspective, how has the field of glycobiology evolved through the past years? And could you share with us some of the most significant milestones that has been achieved in the last decade?
Well, I could summarize briefly that the first milestone, I would say, was finding that these glycans are mainly linked to proteins, producing what is called glycoproteins or proteoglycans, or linked to lipids. The other milestone would be to understand the structure of these compounds. Most of the proteoglycans, that's the class that I study, they have repeating units of disaccharides, which means two saccharides. But the structure varies a lot of these disaccharides. And we don't have, like in protein, there is no template for the synthesis of these compounds. So up to now, we really do not know how are they synthesized. We have a good idea of the enzymes, but what is the code? So we believe the code is in the arrangement of how the proteins, the enzymes responsible for the synthesis, are arranged in the reticulum and in the Golgi. So that's another milestone. Another milestone, just so that the audience can understand a little bit better. For instance, glycoproteins and glycolipids are related. There is one sugar difference in the ABO blood system. So that's one sugar change, and you may have a terrible rejection if you infuse a different blood type. So the blood type system and the discovery of that was very, very, it was a milestone. Other milestones, I would say.
Now, let's talk about you, Professor. Throughout your distinguished career, what do you consider is your most significant and memorable achievement? What is your primary research interest at this moment? Are there any key questions that you are seeking answers to?
Yes, I would say to you that our research is centered today on the interaction between the cell membrane and the extracellular matrix. How the crosstalk between the cell and the extracellular matrix. When I was a young researcher, people used to think that the extracellular matrix was amorphous, didn't play any role. And now, 50 years later, we know that the extracellular matrix is well structured, the arrangement is not by chance, and the crosstalk between the extracellular matrix and the cell is made through interaction of the cell membrane. And we study that. We study a specific class of glycan that's called heparan sulfate that's present at the cell surface. For instance, we found out if we knock down that heparan sulfate from the cell, we change just knocking down that specific compound, we change totally the arrangement of the cell, the arrangement of the actin. And we found out that knocking down a compound that's at the cell surface, it leads to less interaction with extracellular matrix to fibronectin and connection with the cell cytoskeleton through uncoupling of vinculin from actin. So a lot of names, but in other words, if you take away just that compound, you turn that cell into a very potent uh, tumoral cell. It was a normal cell, and we studied that in endothelial cells. So that cell also becomes more angiogenic, which means more easy to spread into the blood and do new vessels. And also, we are studying, as other labs, uh, what, how, how can we explain the synthesis if there is no template? So we are studying this, the enzymes, the location of the enzymes in the Golgi apparatus, in order to try to understand if we change just one of the enzymes in the whole synthesis, what would be the effect? How this affects the cell behavior and the synthesis of that glycan, and several others. We have lots of students and postdoc working. Nowadays, unfortunately, my time at the bench is not as much as I used to be due to other commitments, but I'm still there discussing with the students and the postdoc and other staff members.
Professor Nader, biomedical science is truly, undoubtedly, a very challenging and difficult field. So, throughout your entire career, looking back, what are the biggest challenges that you have to face?
It's not easy, may I tell you. I would say in the beginning, I was more dedicated to the lab, even though I always had classes, I always teach because I believe in for undergraduate. But how did I get involved in science politics? Initially, within the university, because I was the dean or sub-rector, I don't know, it varies the names and in different universities, but I was responsible for all undergraduate students in my university. Then I was the dean for graduate programs and research. And at that time, I start being more related with political issues regarding science, technology, and innovation and education. And due to several uh, things that happened in my life, I became initially the vice president and then the president of the Brazilian Society for the Advancement of Science. And I people thought that I was good. I don't think so. I was just playing my role, that is to fight for the best for our country and trying to convince government that without education and science, technology, and innovation, there will be no progress. And that's the way that developed countries evolved. So I was deeply involved in several laws and amendments to the Constitution that were made during that period. And lately, I became vice president of the Brazilian Academy of Science. And in 2021, I was elected as the first woman president of the Brazilian Academy of Science. So I had to go on with my research in order to have grants to keep the lab running. So it means I had to really make some decisions. And my daughter at that time was already going to college, and she was fantastic. My husband had died, unfortunately, and she was fantastic. She understood and she helped me. She said, "Don't worry if you are not going to be available so much as you used to be, but it's important that you do what you are doing." And I'm really proud because now she's exactly doing the same things. She has two kids and she still fights and works for education. So I think I have a great, great life. The achievements, the significant and memorable achievements that I had as a professor on tutoring and supervising and watching the careers of my students unfold. That was fantastic. And it is fantastic until today. That's something that nobody can take away from you.
Being both a female scientist and the first female president of the Brazilian Academy of Sciences, how do you evaluate the scientific situation for women in Brazil right now?
Okay, that's a fantastic question because even though female are now the majority in different areas of research, of graduate programs, they still are not in the top positions. For instance, I'm talking here in Brazil, okay? We have around 54% of women in graduate programs, which means equal. But if you go to research, we have a fellowship that's given to the top scientists, and the majority are still male, which means that even though women approach it, they still, in some areas, are not at the top. It's changing, but slowly. The slope changes very slowly. And we need a change that's going to be much, much faster in order to accomplish everything that we want. Uh, Other examples in medicine, biomedical science, majority of women. It's not good also to have the majority. You need to have diversity, or else I'm going to be in just empowering women. That's not the purpose. It's equal opportunities that we need to fight for. So, rectors. Here in Brazil now, we have something like 25 women that percent of the rectors in the federal universities that are women. It's a huge change. At my time, it was 0%. Then, which means that we changed, but we need to change more. It's still a long way to go, but we are changing that. I don't think that affirmative action for those positions would be good for the group, because you don't want to have them be looked as second class citizens because you're talking top. But if you don't put your name available for selection, and women have this tendency. For instance, here in Brazil, there is a quota for women going to the parliament. They don't, we don't achieve the quota. It's crazy. So it means that we need to change the way we teach our children when they are young. We need to have more of my parents. Okay? They told us, they told me and my sister, we are just two girls, and they told us that, and we really believed. And they, as I told you, they didn't go to university, but they had this fantastic intuition that education is the best you can give to a children, to a child, in terms of inheritance.
From your perspective, what are the main obstacles do you think that women innovators and female scientists have to overcome in order to pursue their passion?
Women have several appointments besides going to higher education. And here in Brazil, the same as in Vietnam, as in other rural population, don't have the same access as we have, as it's available for urban uh, population. But here in Brazil, uh, we had several programs, and we still have that dedicated not only to women, because here in Brazil, besides the gender problem, we have also a race problem, a societal problem, an economical problem. Okay, so if we look at inequalities here in Brazil, I would say that the disparities go beyond, as I mentioned, beyond race, beyond socioeconomic background, geographic location. Brazil is huge. So we have a diversification of problems. If you look into the south, southeast, northeast, the north, and how to handle all this. So, how can we change this in a country the size of Brazil, and with an economy that's getting better, but we don't have the amount, and we still do not. That's something that I have been fighting for, I don't recall, so many years. Education and science are not expenditure, they are investments.
In a world where gender based discrimination persists, particularly in developing countries such as Brazil and Vietnam, how do we motivate women to keep pursuing their passion? And do you believe that education plays an important and crucial role in promoting gender equality in science as well as many other professions?
Well, STEM is really important to develop a country in terms of, if you look at innovation, industry things, okay? Because you need to have scientists, technology, engineering, mathematicians, but you also need the social science. You need all of that. And uh, STEM education in Brazil is very similar to, for instance, the world. We have we were increasing the number, for instance, of female going into STEM, but now it's stopped. It's around 10 to 30%, depending on the area. It's not that much different from other regions of the globe. So, if we want to have STEM changing the environment as a whole, we need to have all genders. And that means we need to change the way Females, for instance, look at STEM. We need to change we need to show them model roles for going to STEM. We need to change the way parents behave because that's also important. Whenever I see that, young, I have several grandchildren, but now I have one that's going to be 5 and the other one that's 6 months. And there is a tendency to give to the girls a doll, pens so that she can play cooking, and for the boy, blocks to play as engineer. Why not do all for all? Why a man cannot cook? He needs to know how to cook, to change a diaper, and that starts when they are young at home. So parents need to change. I had this. My parents, Blue, were really important into my life. They didn't go to university. They didn't go to college. Okay? My parents, they used to tell me that don't let anybody tell you what you can do or not do. You always need to be ethical, and there is no limit except the limit you set up for yourself. And that's true. What is the difference? Of course, the bodies are different. The strength, the muscle strength of a woman and a man, to talk just about those two genders, okay, are different. But that doesn't mean anything in terms of your brain capacity. And in order to solve problems, it's very important to have different views. And if you have exactly the same group working on a topic, you are going to have an homogeneous approach. And that's not good. That's not the way to solve science. Science needs different approaches.
And from what your parents have taught you to not take a no from any person, I wondered, have anybody ever tell you no? Have you ever faced such significant gender-based discrimination throughout your career?
I had, when I entered the medical school, about 10 to 15% were female. The medical school nowadays is female that predominates. But when I was at the medical university, at the medical school, uh, 10 to 15% were female, which means the majority was male. And we had to impose ourselves and not let anybody try to dismiss or try to block, undermine our pursuits. And that was not easy. But we had, it was interesting. I don't know if it was because it was during the dictatorship that we had here in Brazil for too many years. So I don't know. I don't know what happened, but our group of girls, females, we really did a fantastic job together. And we also brought our male colleagues to understand the importance of having us as partners and not as someone below their level. And most of my colleagues from that time had important positions in their academic lives. So I think we had a common enemy, the dictatorship that was going on. And we all joined forces to fight against that. And that made a difference.
Here in the Win Future Foundation, we have a special prize category dedicated only for women. That is the Win Future Special Prize for Women Innovators, to not only recognize the contribution for the esteemed female scientists out there, but also bolster their representation in both domestic and international ground. So how do you feel about the initiative of In Future Prize to specifically acknowledge the achievement and contribution of women scientists and female innovators? And do you believe that these initiatives will further motivate and empower the women in science?
Well, I strongly believe that initiatives like the Win Future Prize, special prize for women innovators, are invaluable in the way you recognize and the amplification of these contributions of female scientists can impact other female scientists and impact society. Because it's not only the impact on the scientific community, it's very important the impact on society. And I was reading a lot about the Win Future Foundation, and it's amazing. A young foundation with a fantastic job, with a board that selects the winners of the prize, so diversified from different areas of the globe, from different origins, from different religious background, from different races. That's diversity. That's very, very important. So I want to congratulate. And we need more of your foundations that travel the same pathway. There are not too many prizes for women in science.
If you could address the young, bright women, the female scientists of our time, what advice would you offer to keep inspiring them, to keep pursuing their passion, and motivate them to make a career in science?
I would say my message uh, would be quite similar to the one I received from my parents, Blue. Never let others define your limits or undermine your potential. If you bear in mind this belief, you'll be able to navigate, to cross the challenge of academia and research. Also, I would say you must have confidence to push back against discrimination. You need to believe in yourself. And that's most important. If you find joy and fulfillment in doing science, then you absolutely belong in science. And your voice and your contributions are most and truly valuable for the global society. So believe in yourself and find joy. You have to have joy in whatever profession you choose, not only in science, but you need to feel that you are comforted, that you have contribute to change a tiny little bit to help achieve the 2030 agenda, to help to achieve the 17 OSDs, the Sustainable Development Goals. And you're welcome to this fun trip that means being a science in a global world.
Professor Nader, your dedication to glycobiology and your advocacy for women's rights and gender equality in education is truly commendable. Thank you so much for joining with us today and sharing your valuable perspectives. And to our dear listener, thank you very much for joining with us on the conversation today. And we hope that our conversation have ignited your curious minds and appreciation for the world of science. And don't forget that the Win Future Foundation is still calling for nomination for the 2025 Win Future Prize. Check out the link below for more information. And as we conclude this first season, we would like to extend our deepest gratitude to our audience from all around the world. Your contribution and support is instrumental in making this podcast a success. Stay tuned for more exciting new episodes ahead, and thank you and goodbye.